Hi guys, welcome to your phase change chapter 2 notes. In these chapter 2 notes, we're going to tackle the EQ. Why do different substances change phases at different temperatures? So let's get these things going. These notes are not nearly as long as last time. We do have quite a few key concepts though. So we're going to go through our chapter 2 key concepts. We're going to go over the idea of freedom of movement, molecular attraction, and then cover the topic that water is weird. So let's go through our key concepts. There are 8 again. So sorry that there's so many in this unit in particular, but just how it shook out this time. So number 1, when energy is transferred to or from a substance, it can change the molecule's freedom of movement. So when you transfer energy to something or out of something, we can change this freedom of movement. We're going to make sure to define that today. Transferring energy to a substance increases the kinetic energy of that substance's molecules. And then transferring energy from a substance decreases the kinetic energy of that substance's molecules. So when you transfer energy in, you increase Ke. When you transfer energy out, you decrease Ke. So pretty simple right there. 4, whether or not a phase change occurs is determined by the interaction between the kinetic energy of the molecules and the attraction pulling the molecules together. So what this means is that whether or not you can melt something, freeze something, evaporate, condense, sublimate, or deposit any sort of phase, or any sort of substance, I should say, it all depends on how fast are the molecules moving and also how strong is the attraction that is trying to hold them together. And that's going to make more sense when we go over what molecular attraction is. So here we go. The molecular attraction of a substance never changes. And different substances can either have weak or stronger molecular attractions. And then the last 2, a phase change occurs when the kinetic energy increases enough to overcome the attraction between molecules. So a phase change occurs when the kinetic energy increases enough to overcome the attraction between molecules. And then a phase change occurs when the kinetic energy decreases enough so that the attraction between molecules pulls them together. So we're going to go over this, but keep this in mind. We're going to talk a lot about Ke, which really is just the thermal energy. And also we can work in the temperature as well, but we're going to talk a lot about the Ke of these molecules in these substances and how if you increase or decrease the Ke, that is really what is causing these phase changes based off how strong the attraction is between the molecules that make the substance. So I know that was a lot. What I would like you guys to do is take 2 minutes to go through your notes, highlight, underline, write questions, circle vocabulary. If anything doesn't make sense, just raise your hand, let me know, and I'll be glad to explain it. But I'm going to go ahead and move on. So let's talk about freedom of movement. I know I use that term a lot in our key concepts. So freedom of movement is the way molecules in a substance move around relative to each other. And so we've already kind of covered this without really giving up the phrase freedom of movement. But when freedom of movement changes, then a phase change has occurred. So when we have solids move in place, liquids move around each other, and gases move away from each other. So if something within a substance, well, let's say substance molecules were moving around each other, and then they went to moving in place, we know that it went from a liquid to a solid, and now we have frozen. So we're definitely going to talk about this idea of freedom of movement, but solids move in place, liquids move around each other, and gases move away from each other. So a little bit more about freedom of movement. So freedom of movement increases when temperature increases due to thermal energy being transferred into a substance. So when you raise the temperature of something, you're raising the amount of Ke that the molecules in a substance has on average, because remember, temperature is the average. When you increase that Ke and you increase that temperature, then you're going to increase the amount of freedom of movement. So for example, in a solid, it might move in place. And then if you raise the Ke or raise the temperature, it then may go to move around each other. It might have more freedom of movement. On the opposite end, freedom of movement decreases when temperature decreases due to thermal energy being transferred out of a substance. So the opposite of that, if you take Ke out of if you take thermal energy out of a substance and you decrease the temperature or you decrease the amount of kinetic energy the molecules has, you will then decrease the freedom of movement. And then you're talking about things condensing or freezing. So I know that was a little short break, but go ahead and take another break. I want you to highlight, write questions, underline, key vocabulary, circle things don't make sense. If you need anything, let me know. But we're going to go ahead and go over the last couple topics of these notes. Like I said, they're not too long this time. So molecular attraction. So molecular attraction is a pull force between 2 molecules. So molecules are made of the same things. So the same molecules or the same atoms They like to attract to one another now, but it's by varying degrees. So molecular attraction is always the same for a substance. So gold is always has a strong attraction to gold. Gold wants to connect to gold, but oxygen does not really care. Oxygen does, I mean, you can have oxygen connect to other oxygen, but it's not like really trying to attract itself. So it has a weak attraction, we say, and that's all going to make sense, hopefully, with what we cover next. But molecular attraction is the pull force between two molecules. Everything has an attraction to itself, but of different degrees. So gold is stronger, oxygen is weaker. So let's talk about that difference between strong versus weak. So strong molecular attraction, so these require a large amount of thermal energy transferred into the substance to change phases from a solid. So for example, iron. If you want to turn iron, like solid iron, into a liquid, you need to raise its temperature to 2,800 degrees Fahrenheit. That is a huge amount of thermal energy that you need to transfer into that substance in order to get the molecules moving away or moving around each other and increase that freedom of movement because they are so attracted to one another. Think of them like little magnets that the iron wants to be connected to the other iron so badly that until you raise the temperature up so high, will they start moving around each other and loosen up a little bit. Then on the opposite end, we have weak molecular attraction. So these require a large amount of thermal energy transferred out of the substance to change phases from a gas. So for example, oxygen. Oxygen does not really care to connect to other oxygen. It will do it. There is an attraction between oxygen, but it's very weak. And so that means that we need to really lower the temperature. We need to transfer a lot of thermal energy out because we don't want that oxygen moving around too much. So you can actually freeze oxygen at negative 361 degrees Fahrenheit, which is extremely, extremely low of a temperature. But if you get it to that temperature, you are now going to have enough attraction to then bond to each other to then create that solid. So strong, it's harder to melt and evaporate. Weak, it's harder to freeze and condense simply because the different amount of attraction they have, the different strength of the, my metaphorical magnets. And so lastly, we have here, water is weird. So as we've learned, when an object lowers in temperature, you should expect the density to increase, but water is weird. So, but when water freezes, it becomes less dense, allowing ice to float on top of liquid water. So this is how it works. This is because water crystallizes when it freezes, which does not allow it to compact easily due to the shape of the crystal. So water, in other words, so when it becomes ice, when it freezes, it forms these crystals, like all the molecules crystallize, and that doesn't allow them to really fit together well. They don't allow it to condense and like get more compact together. And so they actually spread out. And that's why it becomes less dense. Now, other things do this, so silicone, gallium, arsenic, and germanium. Those are other common ones that will, when they freeze, they become less dense because they crystallize. So it is definitely an interesting thing to think about as we go through this, but wanted to give you this information because we keep talking about water in chapter 2 and why water is a little bit odd. And this is why water does what it does. So that was the last of your notes. What I want you to do is just go ahead and pause me again. You're going to highlight one more time. You're going to write questions. You're going to unlike key vocabulary. You're going to circle things that don't make sense. You're going to ask me for help. But I'm going to go ahead and explain your summary. So for your summary, your EQ, why do different substances change phases at different temperatures? To answer that correctly, you need to have these 4 parts of your criteria for success. You need to explain what molecular attraction is. You then need to give examples of substances with strong and weak attractions. You need to explain how one can overcome a strong molecular attraction to change phases. And then you need to explain how one can overcome a weak molecular attraction to change phases. So if you cover these 4 topics and explain them thoroughly with some detail, you will certainly answer the EQ, why do different substances change phases at different temperatures? If you guys need anything from me, just let me know. But good job, guys, getting your second set of notes done for phase change.